Of Megan, our education projects person, and she'll be answering questions via the YouTube feed. Megan's shy, she doesn't usually come out on camera, but she's waving at everybody.
I understand that.
Also, big thanks to Cassie and Mike, our video people, for bringing us to you today. So for the next hour, we're going to talk about the structure of what the Internet of Things, or IoT, is. We're going to look at a couple projects. We're going to look at some services that run on the Internet. And we're going to look at some hardware that'll actually serve your project needs. So if you have specific questions, please fire them off to us, and we'll do our best to get you specific answers to the stuff that you're curious about. I think to start with, we kind of want to define IoT, the Internet of Things. And Mary, this is I would say this is a discussion topic. So when I envision it, I imagine a connected device, usually a microcontroller or a single board computer, and then maybe a data service or something like IFT. And for those of you who don't know IFT, that is if this, then that. And I think, did you just hook something up to IFT?
I didn't hook it up to IFT. I was actually using Cayenne, but we'll get into that in a little bit.
Yeah, maybe we'll scroll through some of the services. The other way is for me to use a web browser to actually control a device that's remote to me. So what do you, like when you imagine the Internet of Things, what do you think about?
Well, I just think about like what started the IoT craze, and looking in terms of like what data are we trying to connect and what are we trying to do with that data, and why the internet plays an important role in that. So I like to think of it in terms of, well, here at SparkFun, it's a piece of hardware that we've connected to the internet to perform some function. So that's sort of my hackerspace definition of it.
And I think, like if we expanded that out, it's two computers talking to each other.
Yep.
And really, like, it's just stuff on the internet. I think there's a lot of, I don't know, I see a lot of mumbo jumbo with it, but it's just stuff talking to each other over the internet. And I think the common ways that things talk over the internet are through URL requests, or APIs, application protocol interfaces, and then a specific machine language for passing information across the internet, which we call MQTT.
Yep.
So, and we'll kind of explore a little bit of that. But for those of you who kind of are new, maybe dabbling with this in education, I may just look up something on my computer really quick to kind of look at how a query is structured over the Internet of Things. So Mary's got a project for her plants over here, and she set up a bunch of stuff on her plants. And that project is driven by an ESP8266, which is an Arduino-enabled microcontroller. This is one right here. And this microcontroller hooks up to our wireless network here in the office. And then it actually, in Mary's case, uses basically a URL, a Uniform Resource Locator, to ask the internet for something, or to give the internet something, to give another computer a piece of information. And with regards to your project, what's it giving?
So right now this project is actually hooked up to the ESP8266 and is using the soil moisture sensors and some digital temperature sensors, and it is actually sending that data to a service called Cayenne, which has been developed by My Devices. And the time to getting started with Cayenne and the ESP8266 is less than 5 minutes, and that's why I chose it for this particular project.
So all of these devices basically use an HTTP scale, and they create this, they create a web request, and then they tack data on the end of that, or they tack a question on the end of that, and that gets turned back. So when we talk about a thing, like Mary's 8266, this can send out that web request with some data attached to the end of it, and that gets stored someplace. And then it can also call that server, this is a client, can call that server and ask for a piece of data. So it's not all that complicated. It just has to be formatted correctly. So, and you've got some specific thoughts on your project, is that true?
With regards to what?
Well, just kind of how you built this, what drove you into it.
Yeah. So all of these plants used to live on a windowsill in my house, and they stopped getting attention from me. So I decided that I wanted to build a project so that when they needed to be watered, I would be alerted when they needed it. So this is sort of the first iteration of the project. Eventually, I would like to make this all wireless and just have sort of like wireless nodes that go in each plant. But in the Cayenne, on the Cayenne webpage where I have my project, I can set up text and email alerts. So if the soil moisture gets below a certain threshold, it will send me a text alert that says water me, and it will tell me which plant it is that needs to be watered. If the soil temperature drops too low or is too high, I am also alerted, so I know that I need to put a cooling fan on there, maybe wrap a little towel around it to keep it warm.
Very cool. Do you want to get into some of the specifics of how you did this?
Sure. And in fact, there's a GitHub. I have a GitHub repo for this, which I think, Mike, do we have the link for that?
I don't have it on screen, sorry.
Okay, that's fine. So in a minute here, there'll be a link to the screen to my GitHub repo that will show you. Okay, look for it in the comments. And it has all of the code, and there's also a SparkFun wish list for the parts, and there's also a README which goes through resources for getting started using Cayenne, as well as resources for processing your data once you have it. And there's so many good resources for doing that. I like to use Matplotlib. So this is my project dashboard right now. So these are the 5 different plants that I'm monitoring, both the soil moisture and the soil temperature. And I'm also trying to get the ambient light, but I'm having some problems with that right now. And then eventually it will also give me air quality sensor readings, humidity, pressure, and then ambient temperature of the surrounding system. And this is just so that I can become obsessed and take better care of my plants.
Can we talk a little bit about Cayenne and how Cayenne works?
I would love to. It's actually incredibly easy. So if you navigate to my device, it's cayenne.mydevices.com. You'll be first met with a screen that says set up your account. So you'll set up your account. Once you've set up your account, it's going to give you your, well, I'll wait for you to pull it up because it's easier.
So it logs into my dashboard, and it automatically goes to your page, I think because you're logged in.
Yeah, we can go ahead and log out. That way everyone can see what it looks like.
Or we can create a new project.
Yep, we can do that.
So, test. So I'll just call this test. So part of the Cayenne thing is that it'll walk you through doing the whole thing with the video. You get like a whole video feed on this, and you can walk through the steps, and it'll tell you how to.
And in the GitHub repo as well, I've created a template that's very just copy and paste the info that you get from Cayenne. And so with that, you'll be able to send how long your device has been turned on. So you'll see it within 2 minutes, the time that your device has been on, pushed to your project on Cayenne.
So if I click on test, and I get here and I click down, I'm going to add a new device or widget. And actually here is our ESP8266. So in test, we've added this, and it gives me an MQTT username here. It gives me a password, gives me a client ID, and tells me about the MQTT server. Now, as soon as I provision the test code that you would write and load to the ESP8266 device, it will connect to that server, and it will compare those passwords and codes, and that will provision the channel with that device.
Right, and in the Arduino code, the template that you'll see in the repo, there's actually a place specifically for you to copy and paste the username, the password, the client ID, and then that's how your ESP8266 thing dev board knows to connect to this particular project on Cayenne.
So if I click on this again, and I'm going to close this up right here, I think I have to provision this before I can actually add anything in terms of the dashboard, the output from this. So if we wanted to look at the code, I think I have a rough ESP sketch here. And I'm going to call this. And here is, I have some ThingSpeak stuff. I don't know if I have a Cayenne.
So if you navigate to that GitHub repo,
There we go. I have a Cayenne,
Okay,
actually.
cool.
So this is an early Cayenne sketch, and here's the token in that sketch that I pulled from the provisioning on the website. So I enter that Cayenne authentication token in there, and then this actually, with the library, with the Cayenne library, plugs that in as it passes that GET request, that URL GET request, and passes the data with it. Megan, do we have any questions so far? Okay, great. I just wanted to stop and make sure that that if anybody had any questions, we were ready to answer that stuff. And I'm going to go back to Mary's dashboard here. Can you talk a little bit about how you built this?
yes. So in order to create one of those little tiles, it's actually done in the Arduino code. And let me see if I can't pull it up here. Actually, I might send it to you so that you can
Yep,
pull it up, because
great.
then I'll be able to step through it.
So again, if you have specific questions on the hardware we're using or kind of how we got to all this, Mary has a GitHub repo that has her example code in it, so you can dig in and experiment with this yourself. And we'll make sure that that GitHub address is on the YouTube channel, and it is.
On the description.
Mike has given me the nod, so we're live with that. It's also remarkably easy, I think, with tools like Cayenne to get started.
All right, you should have the link to that.
Okay.
And it was, I mean, from taking the ESP8266 thing dev board off the storefront to getting connected to the internet and pushing data was less than 5 minutes with the template.
Yeah, and I'm pulling up Mary's.
And another thing that I really like about Cayenne is that you get to choose how you have that information displayed. So if you know that you're going to take in an analog sensor and it goes from 0 to 1024 on an ADC scale, what you can do is set that up rather than as a bar graph that tells you what it is incrementally throughout time. You can set it up as a meter so that it looks like, you know, sort of like a car analog meter. And there's different ways that you can set up your dashboard so that you can visualize the data the way that it makes the most sense to you.
So I'm actually on Mary's GitHub page right now, and the nice thing is Mary's really good about documenting stuff. She's one of the stars in our engineering department when it comes to getting ideas down in hard copy for folks to use. And you can see as you open up this GitHub page that there's a description about getting started. Mary talks about using MQTT and your password and client ID and the stuff you need. There's a link to hardware required.
It's just a SparkFun wish list of all the parts that I used.
Great, perfect. And there's some supporting resources here, which I'm super stoked that you use the matplotlib.
Oh yeah, I mean, I'm a Python enthusiast, so that's...
Very good. And I tend, I've been playing with that lately. I tend to also use processing because processing is 0 to graphic, data graphics in no time flat. So there's no link to processing here, but the processing resources are so ubiquitous that if you really wanted to do that, that would be available as well. Mary's got a lot of contextual stuff here about kind of the background of hardware and the internet. And then as we go up, if I open IOP,
Yep, Internet of Plants.
Internet of Plants, the IOP folder. Come on. There we go. You can see, I haven't downloaded this, but Mary has included a lot of libraries on here.
Yeah, so Cayenne has actually updated how they're on their library end. It's actually much more seamless, but it does mean that there are way more header files that need to be included.
And then down here, there's some constants that are connected to the SX1509 sensor.
Right, so one of the drawbacks to using the ESP8266 is that it has very limited I/O, so I actually attach an I/O expander to it, and that's how I'm able to connect, 15 sensors up.
So can we talk a little bit about that? So Mary used something that we call a MUX.
So I also used a MUX on the analog pin, but to expand the digital side of it, I also used the I/O expander. So I have the SX1509 I/O expander, and then I also have an analog MUX for handling all the soil moisture sensor readings.
Okay, so a couple of different sensors on there. Mary's got the SSID provisioned in here, which is on our guest network with a password. And then below that, her username, her password, and her client ID are in there. So actually, if you're opening up this GitHub, you're going to be sending data to Mary's project.
Right, so that's why I encourage you to use mine as a template for how, if you wanted to do this project, but in the template, it has all those spaces blank with directions for where to get those,
So
where to get that information.
If I go back here, if we cut back to my screen, you can see when I opened up and added that device on Cayenne, I got the client ID, the password, and the username on here. So I would take these, if you were going to do this, you would take these and put them into Mary's sketch where Mary has her numbers.
Yep.
So then the setup is super simple. It's just a library call, cayenne.begin, and then it sends your username, your password, your client ID, and it provisions over the wireless network by passing in the password, all rolled into one. I'm looking for in the loop.
So if you scroll down past all of my I/O code,
Yep.
and past all the digital writes and reads, you'll start to see where I can, where I'm going to be making these blocks that you'll see on the page. So continue down. There we go.
Okay.
So virtual write is how Cayenne interprets your data into that little graphical box that shows the value. And that's how easy it is. So as soon as you put down cayenne.virtualWrite and then whatever it is that you want to send, so in the template it will show just the last millis example so that you can see how long your ESP has been turned on since you connected to the internet. And you can have, I mean, so far I haven't been able to break it just by adding a ton of them. I'm sure that there's a limit, but I have not reached it yet. But I have 15 on there now.
So, and you can see time is actually based on the last millis.
Right.
Yep. And then all of these dashboard tiles are connected to the variables that we're writing here under virtual write.
That's right. And when you see it first posted onto Cayenne, it'll show up however you labeled it in your Arduino code. So it first showed up as SM4, but SM4 isn't very meaningful to me. So when I see the tiles, I know, okay, that's the soil moisture on the fourth sensor, but I know that that's my pineapple, and that's the plant that I'm monitoring. So on the tiles, there's actually a setting so that you can change the name of that tile so that it's something more meaningful to you. Another cool thing is if you go back to Cayenne,
Okay.
and now you'll see a little graph bar and a little settings icon at the top right hand of each of those tiles.
So I'm going to just go to pineapple moisture,
Yeah.
pineapple soil moisture. Okay, there we go.
And so that's giving me the data from the last hour. So that little dip that you see there was when I removed the sensor because I wanted to make sure that my text message was set up correctly. So now I should receive a text message that says, hey, water me, because this is essentially going to read as zero moisture. Oh, and I did. Pineapple soil moisture has reached threshold value. Connect to, and then it just says water me.
Nice, nice. One of the nice things also about the graphing stuff on this is that it's scalable. So, we're looking in hours. I can set the graphic up to go days, weeks, and if I went out a month, I think I'd lose the graph pretty quickly here. Yeah, it's just spinning. But when I go back to hours, so you get variable windows on this. You can adjust these by doing the custom page, and it'll give you a window of from when to when.
Yep.
You can also download the chart data.
And
So-
that is my favorite thing, is that I can just download my data and then process it using Matplotlib. The one that I've just found that I'm a huge fan of, it was in the README. I just discovered it today, so that's why it's not right there. So if you go to the
so
README.
let me go to the README.
Mhm. Oh, you want to go to plant monitoring?
Oh,
You're showing them all my secret stuff.
Sorry.
Okay, that's fine. Alright, and then if you scroll
Yeah.
down, keep going. Oh, okay, go back up.
right.
Data wrapper. So this is a really interesting site that I just discovered. You can basically copy and paste large amounts of data from multiple columns of an Excel spreadsheet or from the CSV file that you get when you download your data from Cayenne. You can just copy and paste it straight in here, and it will automatically graph your data for you. But it's not just like you can have it map, you can have it, you can make a contour plot, you can do all kinds of like different types of plotting without coding. So,
Free?
And it's free.
Wow, that's pretty sweet.
Mhm.
There's all kinds of tools like this also in Cayenne. There's a lot of
There are.
lot of ways to work with this, both in a web environment like this, but also locally on your machine from the downloaded data from Cayenne. And I want to make sure that if we've got questions, Megan, we're okay. Thank you. Where are we at? How'd you do the text message?
Oh, that's incredibly easy. Let's go through it.
Okay.
So from your dashboard, go to the user menu, which is on the top right-hand screen. And now you can do triggers and alerts. And all these directions are also in the GitHub repo. So if you get lost here, definitely go check that out.
So I'm going to go if water me is down here, right?
Yep.
Water plants. Yep.
So we can go ahead and set up another one. So do new trigger.
Okay. Name your trigger. How about, is temp? No,
So,
it would be hard. That's right, yeah.
right.
Dry.
So I still have to do a lot more, I have to do much more testing to figure out what's the safe and unsafe data range for the temperature.
Okay,
So let's do soil moisture again. I call it soil moisture low.
how'd I do?
Fantastic.
Okay.
So now what you're going to do is click on the one right above that, and now drag and drop it into the if statement box. Now it's going to have you select a trigger. So I've already got one for the pineapple, and I've already got one for the fig. So let's do snake soil temperature, and that's going to be for the snake plant here in the middle.
Okay,
So the soil temperature, or the soil moisture sensor, goes from an ADC value of 0 to 1024. So that's going to be my min and my max.
so this is gonna be 0. And my max is gonna be 1024. And steps are in 1.
So the value that you want to set it at is, I've been finding that 680 is on the dry side for a snake plant.
So do I go 680?
Yep.
Okay,
And now if you scroll down a little bit below the screen, I want to do if sensors below that,
okay,
and now scroll back up. And then on your then, do setup notification. And you can do email, text message, or you can do both.
I'm gonna do, send a text message,
Okay,
and then I add a recipient.
that's it. And all you gotta do is put in your cell phone number there.
So I'm gonna put in mine.
Yeah, I don't know. Maybe let's do email.
Let's do email, right? Okay, so Jeff, I'm gonna send an email, and I'm gonna say Jeff Branson at Sparkfun. And I'm gonna hit save.
And that's it.
So now, let's see if it works.
Okay. So it might be trial and error for removing these. Okay. Will you
Okay.
pull up the dashboard? Because that would be the easiest way to see whether or not it's working.
Okay,
So let's see. Oh, and these are also updating every 2 minutes.
okay.
So it'll take at least 2 minutes before we know which one was pulled out.
So snake moisture right
Mhm.
here,
Yep.
right? Is that 1024?
It's at 1024 right now. So let's see if it's this one.
And then if you take that out, it'll drop, right?
Mm-hmm.
Because the resistance goes up infinitely.
Yep.
It should go to 0.
Yeah, it should.
Does it go to 0?
The A to C value will go to 0.
Okay.
Okay, so it doesn't look too bad.
And let's come back to the email, because I should get an email in the next 2 minutes.
Yep.
Very cool stuff. Are you taking them all out?
Yeah, because I can't find which one.
Awesome. Yeah, numbers are dropping drastically here.
Okay, good.
Yeah, the snake moisture is at 7 now.
Okay.
So,
Did you get an
I just
email?
got a trigger notification from my devices. If I So there, on my phone, you can see that this has dropped below the threshold value. So we got the email.
And
Awesome.
that took, 30 seconds to set up.
Yeah, that was really quick.
And then about 2 minutes to test because I didn't have my soil moisture sensors in the right place.
Awesome. Mary, we're 30 minutes in.
Mhm.
This is a great project. Thanks for sharing this.
Of course.
Like crazy cool. Wiring guides, hookup guides, where are we at with that? Is it pretty self-explanatory to do it?
I would say no.
Okay.
And if anyone's interested in a wiring diagram, I'm more than willing to create one and add one to my repo.
Great. The other thing is that from an education perspective, I tend to hook up a channel first. One channel, I get it working, and then I add complexity.
It's much easier to troubleshoot one problem at a time, so don't compound your problems before you need to.
And we all know that particularly if you're working with primary education students, they're going to hook up 23 sensors first off and go, mine isn't working, and push it at you. Kind of working with a single channel is a great place to start. I want to talk a little bit about some of the options. We've looked at the ESP8266, which is one of my favorites. It's one of my go-tos. It's cheap, really easy to use, and for years now, this has kind of been my go-to piece of hardware, but all of a sudden things are changing. And more, there's a lot of friendly script for things like the Raspberry Pi, and I can use the pins on the Raspberry Pi. One of the constraints of the Raspberry Pi is that the pins on the Raspberry Pi are digital-only pins, which means that they'll read a high or a low signal and not necessarily an analog signal like Mary's using on the soil moisture. So if you're going to use these to monitor analog conditions, you actually have to add an analog to digital converter on the outside, and there's some pretty good documentation on the internet on that, but the Pis are so cheap and they're so ubiquitous that working with them is super fun and easy, and actually pairing these two things as a project prompt where this might send data to something and then the Raspberry Pi is signed onto a wireless network and scraping that data and building, you could build your Matplotlib
That's exactly
stuff
what I do.
on the Pi.
Yep.
And use the Pi as the data visualization tool. So the Pi is, lots of folks using the Pi. More recently, if you need that smaller form factor of the Pi Zero, super fun little wireless board. If you got space or budget stuff, because these are like $10.
They're $10.
Yeah, so very cheap, very easy to use. I want to talk a little bit about some of the off the beaten path stuff. I'm a big fan of the Beaglebone Black. Beaglebone is Texas Instruments project. Jason has done tremendous work. Drew, they both have really supported this. When you plug this board into your computer, it actually shows up as a drive, as a thumb drive, mounts as a drive, and then you sign into this through a local access port through a web browser, and you can get into the coding environments, and it's really well supported and very, very powerful. And their new iteration, the Beaglebone Blue, I just saw in action today. Sean, one of our engineers, was doing a project with this. It says onboard wireless, very powerful. The connectors are pre-populated, so plugging stuff in is really quick, really easy. The coding environment for this, the Cloud9 coding environment, is super cool. There's all kinds of example code loaded on here, so when you plug it in, you don't even have to go to GitHub and get stuff. It's already on the board, ready to go. But now we get to my kind of...
Now it's your turn.
Yeah, it's my turn. So the last couple of weeks I've been playing around with the Omega Onion 2, and this is a really interesting board. I backed the Kickstarter for Omega, and this is actually the chip right here. So I've got my fingers on the chip. It's about the size of a big postage stamp, and it's in the expansion dock right now. Omega builds a bunch of different expansion docks, and I'm going to kind of point some of them out. This is a Servo expansion dock. So it's got the pins broken out for servos. You just plug this header right in to the expansion dock. You can get a breadboard adapter for the Omega and run these on a breadboard. You just plug your Omega into here and set this right into the breadboard, and off you go. There's a relay, so if you want to isolate a voltage and use a mechanical relay, there's a little relay expansion board. There's a whole bunch of these expansion boards. There's a, if you need to hardwire, there's a Cat5 connector, Ethernet connector on there, so tremendous amount. We went live with a bunch of this stuff about 3 weeks ago, and I've been playing with this. But what I want to do is actually look at how this works, because I think for a classroom setting, this has a lot of possibilities. First off, I actually want to point this out, Mike, to the folks at home. This is a 4G router, and we get ours through Verizon. But this travels with us when we go to conferences and workshops, so we don't have to worry about the internet. And the reason I mention that within an education setting is that if you're having problems with the school IT, one of the options is to actually use a 4G router, and getting your local cell phone company to donate a cell phone router, a 4G router, is a great kind of public relations tool about new technology and education. And then you can run these projects without having to worry about firewalls in traditional education. It's kind of a way to circumvent stuff. We figured this out through a lot of trial and error. So this Cayenne right now, or I'm sorry, this Omega 2, Onion Omega 2, is hooked up to this wireless router. It's hooked up to my 4G router. When I turn it on, it serves actually its own hotspot. And if we can cut to my laptop, I'm going to just pull down my menu, my wireless menu, and you see right here it says Omega 992, and that's actually the Omega broadcasting a hotspot of its own. And the first time you get the Omega, you hook up to that hotspot and walk through a setup menu, getting it on your wireless network to connect to the internet. Once it's on the internet, you're going to update it, get the newest firmware on it, and as soon as it's hooked up and whenever it's on the network, there are all kinds of cool things that you can do. One of the things you can do is connect to that through that network. So I'm gonna go to the SparkFun EDU router, which is the wireless router that this Omega is on. I'm going to open up a browser window, and I'm going to put in 192.168.3.1. It automatically populates here. And this is polling that onion over the network, asking it basically to serve me a web page. It'll take me a little while to get on here. So one of the advantages of the onion is that I don't have to have a monitor, a keyboard, a mouse for each unit. I can have somebody connect to it through their phone, through their laptop. And I'm going to refresh this. Oh. Let me go to it through the web page. I'm going to go to the Onion Cloud. And so I have a cloud connection as well, and this is not through the local network, but this is through the remote network right now. And I'm just going to show off some of the functionality through the remote network, and then we'll log on to it locally. But as long as we've got the router fired up and we're connected, when I go to Device Manager, it actually shows me all of the devices on my account, and this is the cloud service that that Omega that Onion provides. You can see that Omega Onion 9992 is on that list right now. I'll click on that. It shows that I'm online right now. If I go back, I can go to the Onion GPIO, and it actually gives me a graphic of what we've got up here. I'm going to select pin 0 on here. Oh, before I do that, it gives me a little error. I have to tell it what device I'm talking to. I'm talking to Onion 9992. I'm going to grab pin 0. I'm going to call pin 0 an output. And I have, if I'm not mistaken, just checking, yep, I have an LED hooked up to pin 0 right now. I'm going to sync this up just to make sure everything's talking to each other. And then I'll change that value from 0 to 1. And when I do that, my LED goes on. So you can see that my LED is on. And Cassie, if you'd leave us on that shot, I'm going to change my value back to 0, and when I do that and it syncs, the LED goes off. I'll change it back to 1, and you can see it sync up, and I'm turning those LEDs off and on remotely on this board. So I'm actually doing this through Onion's server, which is really nice. I mean, this is probably the fastest you can get to an Internet of Things device that I've seen. I know there are similar things for the Raspberry Pi now. This is super clean, and did I mention that these units are about $9? They're very, very inexpensive.
What would you say the limitations are of the Onion Omega?
It's a good question. It's not as fast a processor as the Pi, and there's some memory limitations to it. The Pi has more memory and it's a little faster.
What about in terms of just general I/O? Like, would I be able to hook up this many sensors, or what kind of, like,
I think you'd
does it
have to
do
and I haven't explored a lot. I don't know how many sensors do you have on there?
There's 10 on there now.
Well, you absolutely need the analog to digital converter on this, same as with the ESP8266. But when I'm working through the cloud, you can see that certain pins are broken out on this, and they're actually different as you move from breakout board to breakout board. Slight differences that I've observed, and I know that Bruce from Onion is probably watching, so I hope I don't make any mistakes here. So one of the things that we were talking about this morning was kind of like a home monitoring application, and I wanted to model, let's say, a garage door. So I've got a button on the board, set up on the board, and I want to make sure that I've got the right pin on this. I believe that I'm going to have to take my wires here for a second, because I use the same color wires for both pins, so I can't separate them out. Okay, so this is pin 7. Right here is my button. So I'm going to go to pin 7 on this, and the reason I'm going to do this, I'm going to say this is pin 7, and you can see right now the value on pin 7 is 0, and when I sync that, it stays 0. If I push that button and I resync it, and I get my little gear, it's talking, I get a 1 on that dashboard, which means that switch is closed. Now, if that switch is open, I take my finger off the button and I resync it, it's 0. So that means that's open. I'm not actually applying power to that circuit. Well, if that was a garage door sensor, if I had a mag sensor or a proximity sensor or some kind of switch that a garage door opened, and I wanted to monitor that, I got to work and I went, did I leave the garage door open? Then I could get on and look on this dashboard, and 0 means that switch is open, which means the garage door is open, and then I panic and I either have to drive home, or what I can do is hook up a circuit that closes the button that closes my garage door. But in this case, what I did is I actually hooked up a small motor at the top of here. And when I go to pin 1 is going to be set for output. And when I hit sync and I get the little gear spinning, when I change that value, my garage door is closing. So my garage door goes down, I get my garage door closed, and we shut that off. So I have remote control from that. And this works with any web browser. So I could do this from my phone. I could log in from my phone and do this as well. So I think there's an awful lot of area for project research.
Well, I already got an idea for a project.
You
now.
do, yeah?
Oh, yeah. I mean, just taking the same idea of opening and closing a door. You know, if I was able to monitor my dog at home, and when he would go towards the back sliding glass door, I could have the doggy door physically open so that he could be let out and let back in. So he's a 120-pound chocolate lab, so that
Moose.
doggy door, yeah, Moose is huge, and that doggy door I like to keep locked when I'm not home because you could fit through his doggy door.
Right.
But if I could set up a video monitoring feed where I could see that he needs to go outside and then allow that door to become unlocked at that time, that would be cool.
So there's a webcam plugin for this as well. So
That's even better.
yeah, right. All kinds of cool stuff. So this is kind of like the new hardware for me. I'm really, really excited about this. We've had some great discussion with the folks at Onion, and we're really, really stoked about what the work they've been doing. I want to kind of explore this a little more and look at, this is the web side of things. I'm actually going to connect to the Onion directly, so I'm connected through the web right now. But I'm going to go into my wireless router, and I'm going to select my Omega 9992 because it's broadcasting a hotspot, and my Wi-Fi will connect to that. And now I'm going to go back to that 192.168.3.1. And this is the direct Onion console. So I've connected directly to the Onion. We're not talking through the internet. We're just talking through a wireless connection, a Wi-Fi connection between the Onion and my laptop. I'll log in. When I get that, I've populated, there's a console app. And when you set up your Onion for the first time, you get this console app, and you get all kinds of cool stuff that you can work with on this. In settings, I can go into my settings and I can look at the memory, the storage, how much usage of storage I've got on here. Is it online? It gives me the device status. If I go to the Wi-Fi settings, you can see it's connected to this SparkFun EDU router. If I go back to the home page, I have a GPIO tool on the home page, very similar to the web tool. So I can connect to it locally and control those GPIO pins from a local connection. And I'm going to go back and re-ping that. There we go. And this is a small processor. Sometimes it takes a little while for it to serve up. In the interest of time, because I know we're approaching the end of this, I'm going to show the editor. I really love the code editor for this. This actually gives me, this is Linux, but this gives me a graphical view into the file system on the Omega 2. I created a file called Python files. I'm going to open Python files, and when I do, I have a sketch called blink.py. And here's the code for blink.py. And I can actually alter the code that's on that board remotely from my desktop, from my computer, just by working in this editor and saving my text. And I can go in and type something like hello, whatever, and then save this. What's interesting is I can also connect to this through SSH on my computer. So Cassie, if you can give me a shot on my computer, I'm going to control C out. I'm going to SSH in here to the onion. I've got the command saved. I'm backing up through my command history, and you can see I'm SSHing into root at Omega 9992, and then it's going to ask me if I want to continue with this, and I'm going to say yes, and then it's going to ask me for the password. And now I'm into the root on the command line on my machine. So I'm actually on the Omega, Omega, but I'm talking to it through a terminal on my laptop. So I'm going to do some navigation in this. I'm going to say CD / I'm going to go in, and now I can start to see my files in there. You can see I just used the ls command, and this is a command line view of what we looked at in the editor app on my desktop. I'm going to CD in again, and okay, I'm going to say Python files. Oh. So now I'm in Python files, and I'm actually going to use the Python command and do blink.py, the call for the file that we see up in the background.
Does this editor have tab complete?
I believe it does, and
Okay.
you can see that we're blinking. It's also running my motor, and I need to figure out why that is. But there's my blink. It's actually running that, and there's a pin thing going on here. I got to figure out why I did that. But you can see if I Control-C out. There we go. And I'm going to pull the power out of this, so we're not talking to that the whole time. There we go. So that's an example of running a Python script with the Omega. Megan, do we have questions at this point in time?
Just some people saying hi.
Okay. Well, hey. So that's what I got. You got any questions?
I don't have any questions.
Okay.
I'm just really eager to see what other, what projects everyone else comes up with.
Yeah. I think there's some really interesting and cool stuff out there. We're 5 minutes ahead of 5 o'clock here. It seems like that's a wrap. I want to thank you for bringing an awesome project, and
You're very
thanks to Megan and Mike and Cassie for their support work on video and the internet. And feel free to contact us. Education@sparkfun.com is one of the ways to contact us.
And you can also contact me through the repo listed there. If you have any issues with getting started with it, you can file an issue with that, and I'm very good with responding to those very quickly.
Very good. I think that's all we got. Bye.